It was March 2016. The world was watching a game between one of the greatest Go players of all time, Lee Sedol, and a computer program named AlphaGo. People thought this would be a routine human victory. After all, Go had been played by humans for thousands of years. But then something extraordinary happened. On the second move of the game, AlphaGo played a move that no human had ever considered. Experts in the room gasped. They whispered, "This is alien." Lee Sedol paused, staring at the board in disbelief. That single move didn't just challenge him. It challenged everything we thought we knew about intelligence, strategy, and creativity. And it made the world ask a simple question. How could a machine, just lines of code and numbers, make such a decision? Before we try to understand how AlphaGo did it, let's step back and ask a bigger question. What is AI really? Is it a human robot with thoughts, a computer that thinks like human, or something much simpler but equally powerful? Artificial intelligence, or AI, is not magic. It's not consciousness, and it's definitely not like the sci-fi movie where machines plot and scheme. At its core, AI is a system that can learn patterns from data, recognize those patterns, and make decisions based on them. Think about your email's spam filter. Every time you mark a message as spam, the system learns from it. Over time, it notices patterns, words, sender's address, phrases, and can predict which mails you might consider spam in the future. And that's AI in action. In simpler terms, AI is like a student that studies examples over and over. Instead of memorizing, it finds patterns, understands rules hidden in the data, and then applies those rules to new situations. This is exactly what AlphaGo did. It studied millions of games and learned the strategies and then discovered moves that humans hadn't imagined. And that's why it seemed alien to the professionals watching it. So AI isn't thinking in human sense. It's recognizing patterns, learning rules, and predicting outcomes. But how exactly does it do this? How do you turn mountains of data into decisions that can beat a human world champion? And that's where the real magic begins, with the fuel of AI, data. So now we know that AI isn't magic. It doesn't think like humans. It learns patterns and makes predictions. But here's the question. How does it learn? And where does it get the knowledge to make decisions like beating a world champion in Go, recognizing faces, or even recommending what movie you should watch next? The answer is data. Mountains of data. Every piece of information you create, your photos, text, videos, clicks, purchases, can become a lesson for AI. Think of AI as a chef and data as the ingredients. No matter how skilled the chef is, if the ingredients are missing or spoiled, the dish won't turn out well. In the same way, AI can only make decisions and predictions based on the data it has been fed. For example, consider image recognition. To teach an AI to recognize cats, you don't write rules like if point ears and whiskers then cat. Instead, you show it thousands, even millions of pictures of cats. The AI starts noticing patterns, shape of ears, eyes, fur, textures, and eventually it can recognize a cat and it's never seen before. And that's data in action. You see AI learning from data every day without even realizing it. Netflix uses your watch history to suggest shows. Spotify learns your favorite songs and curates playlists. Even your phone's keyboard predicts the word you want to type next. All of this happens because AI has been fed enormous amounts of data and learned the patterns within it. But data alone isn't enough. Just having millions of cat photo or chess game doesn't automatically make an AI smart. It needs a set of instructions to process that data, to learn from it, and to make predictions. These instructions came from millions of algorithms, the brains behind AI. And that's about exactly what we'll explore next. how algorithms turn raw data into decisions that can outsmart even the best humans. So far, we have seen how AI learns patterns from mountains of data. But here's a puzzle. How does AI know what to do with that data? How does it decide which patterns matter and which to ignore? And how to make predictions? The answer lies in the hidden engine inside AI, the algorithms. If data is the fuel of AI, then algorithms are the engine. Without algorithms, AI would just be a pile of information with no direction, like a car without an engine sitting in a garage. Algorithms are the set of instructions, the step-by-step rules that tell AI how to process the data and learn from it. At its simplest, an algorithm is like a recipe. Imagine you want to bake a cake. You have ingredients like flour, sugar, eggs, but you need instructions. Mix, whisk, bake at 350 degree for 30 minutes. Without recipe, you might end up with a total mess. AI works the same way. The data is the ingredients, and the algorithms is the recipe that guide AI. The mixes, the data tastes the result and improves over time. These algorithms are what allow AI to identify patterns, make predictions, and even come up with creative solutions like AlphaGo, Alien Move. Let's take something simple, predicting the weather. Every day, millions of data points, temperature, humidity, speed are collected. The algorithm takes all this data, finds patterns, and then predicts if it will rain tomorrow. The better the algorithm, the more accurate the prediction. Similarly, in a self-driving cars, algorithms process data from cameras, sensors, and maps to decide when to turn, stop, or accelerate. The engine of decision making is the algorithm itself. Algorithms are powerful, but here's a twist. Traditional programming alone can't handle really complex problems like recognizing a cat in a photo or beating a world champion in Go. That's why we use something called machine learning, an approach where AI can improve its recipe on its own by learning from data. Next, we will dive into the fascinating difference between traditional programming and machine learning and see how AI truly begins to think on its own. Up until now, we have talked about data and algorithms. But here's a big question. How does AI actually learn to make decisions on its own? How did AlphaGo figure out moves that no human had ever imagined? To answer this, we need to understand a revolutionary concept, machine learning, and how it's different from traditional programming. First, let's look at traditional programming, the way computers have worked for decades. In traditional programming, humans write explicit instructions for every possible situation. You, the programmer, tell the computer exactly what to do, step by step. For example, if you wanted a program to detect spam emails, you might write rules like, if the email contains the words lottery, mark it as spam. Every possible condition has to be manually defined. This works well for simple tasks. But as problem gets complex, like understanding a language, recognizing faces, or predicting chess moves, writing every rule becomes impossible. This is where machine learning changes everything. Instead of giving the computer exact rules, you give it data and it will learn patterns on its own. Think of it like teaching a child. You don't tell a child the exact rules to identify cat. Instead, you show them hundreds of pictures of cat, and over time, they learn to recognize cats, even ones they have never seen them before. Machine learning is the AI equivalent of that. You feed the AI massive amount of data. It notices patterns, learns from mistakes, and improves over time. And suddenly, problems that were impossible to code by hand, like playing Go at a superhuman level, becomes solvable. Here's a relatable example. Netflix recommendations. Traditional programming would require engineers to write rules like, if someone watched a sci-fi movie, recommend other sci-fi movies. But with machine learning, the AI looks at millions of users, their watching habits, and identifies subtle patterns. It can recommend a romantic comedy to someone who usually watches sci-fi because it learned that people with a similar taste enjoyed that combination. No human could write a role that captures this complexity. So the big difference is this: traditional programming tells the computer what exactly to do, while machine learning lets the computer figure out the rules itself from data. And the most powerful form of machine learning comes from the neural networks, algorithms inspired by the human brain. Next, we'll dive into neural networks and see how AI mimics the brain to learn in ways that were once thought impossible. So far, we have seen how machine learning allows AI to learn patterns from data. But how does it handle really complex problems like recognizing a face in a crowded room, understanding spoken language, or predicting a winning move in Go? The secret lies in something inspired by nature itself: neural networks. Neural networks are AI systems that modeled after the human brain. Just like our brains have neurons connected by synapses, a neural network has layers of nodes or artificial neurons connected by pathways that transmit information. Each neuron receives input, performs a small calculation, and passes the output to the next neuron. The magic happens as data flows through these layers, allowing the network to recognize patterns and relationships that are too complex for traditional algorithms. Think of it like a giant team of chefs making a dish together. One chef handles spices, another the dough, another the sauce. Individually, they can only do so much, but together, following the flow of instructions and tasting repeatedly, they create something complex and delicious. Neural networks work in a similar way. Each neuron contributes a tiny piece of understanding, and together, they create a powerful system capable of learning incredibly complex patterns. A perfect example is image recognition. Imagine teaching an AI to recognize cats. The first layer of neurons might detect edges and shapes. The next layer notices textures. The next recognizes ears, eyes, and whiskers. And the final layer combines everything to identify a cat. What seems simple to us, just looking at a cat, is actually a complex orchestration of thousands of calculations working together in the neural network. Neural networks are also behind the speech recognition, self-driving cars, language translation, and even creative AI that can generate art or music. In fact, the same underlying concept allowed AlphaGo to learn strategies no human had ever discovered. So, neural network gives AI the ability to learn, recognize, and predict in ways that were once thought impossible. But learning is just the beginning. How does an AI actually get trained to improve, to make fewer mistakes, and to get better over time? And that's where the process of training comes in. So, neural network gives AI the ability to learn, recognize, and predict in ways that were once. We have seen how neural networks give AI the power to recognize patterns and make predictions. But here is a secret sauce. A neural network doesn't start off smart. It learns through a process called training, a process that turns raw data into intelligence. Training an AI model is like teaching a child a new skill. Imagine you want to teach a child how to throw a basketball into a hoop. At first, the ball misses the hoop almost every time. But with practice, throwing, adjusting, learning from mistakes, the child gets better. AI training works the same way. We feed the AI huge amounts of data, images, text, numbers, and it makes predictions. At first, many predictions are wrong. The AI then compares its predictions to the correct answers, calculates the errors, and then adjusts the internal connections in its neural network. This process repeats thousands of times, even millions of times, until the AI can make highly accurate predictions. Think of it like sculpting. The data is the raw block of stone. The AI training algorithm is the sculpture's chisel, slowly removing its mistakes and refining its understanding until a clear, accurate model emerges. Every pass through the data, every correction makes the AI smarter, more precise, and better at solving the task it was trained for. For example, when training an AI to recognize handwritten deeds, we feed it thousands of labeled images of numbers 0 to 9. Each time it guesses wrong, it adjusts the connections between neurons. After enough training, it can accurately recognize digits it has never seen before. This same process is used in self-driving cars, voice assistants, medical diagnosis, and even AlphaGo. The difference between a beginner AI and a world-class AI isn't magic. It's hours or even months of intense training on enormous data sets. Training turns raw neural networks into intelligent systems capable of making decisions, recognizing patterns, and solving problems. But when these networks get very deep, with many layers, they become capable of extraordinary feats. This is where deep learning comes in. So far, we have explored the neural network and how AI learns through training. But here is the next question. What happens when a neural network has not just a few layers, but dozens or even hundreds of layers? This is called deep learning, and it's the game changer that revolutionized AI. Deep learning is a type of machine learning that uses very deep neural networks to process vast amount of data. Each layer in the network extracts increasingly complex features from the data. For example, imagine teaching AI to recognize a face. The first layer might detect a simple edges and shapes. The next layer identifies patterns like eyes or noses. The next layer combines those into higher level features like a whole face. Finally, the last layer recognizes the individual people, even in different lighting or angles. This ability to learn complex patterns automatically is what makes deep learning so powerful. Traditional machine learning often required human experts to manually identify features, but deep learning removes that limitation. Deep learning powers many things you interact with every day. Voice assistants like Siri and Alexa understand spoken language. Google Photos can automatically tag people and objects in your pictures. Self-driving cars can detect pedestrians, traffic signs, and other vehicles in real time. Even AlphaGo uses deep learning to analyze millions of game positions and find strategies humans never imagined. Without deep learning, AI would still be impressive, but it wouldn't be capable of these groundbreaking achievements. So, deep learning is like giving AI a superpower. The ability to automatically discover complex patterns, make decisions, and even outperform humans in certain tasks. But here's the thing. AI isn't just about algorithms or network. It's all around us, quietly shaping our daily lives. By now, we have explored how AI learns, trains, and becomes superhuman through deep learning. But here's a thought. AI isn't just in labs or playing games against world champions. In fact, the AI is quietly all around you, shaping your everyday life in ways you probably don't even notice. Take your smartphone, for example. The moment you type a message, a predictive text suggests the next word. That's AI analyzing patterns in your typing and learning what you are likely to say. When you watch Netflix or listen to Spotify, AI is hard at work recommending movies, shows, or songs based on your preferences. Every click, every watch, every skip feed data back into the system, making it predictions for more accurate. Even your social media feeds are curated by AI, from identifying which post you are most likely to engage with, to recognizing faces in photos and videos. AI decides what you see all in real time, and it doesn't stop there. Self-driving cars uses AI to detect obstacles, predict movements of other vehicles, and navigate complex traffic. Smart home devices like thermostats and lights learn your habits and adjust themselves to make your life easier, all powered by AI algorithms trained on massive amounts of data. The most fascinating part, you don't need to know how AI works to experience its benefits. It's quietly optimizing, predicting, and assisting us at every moment, sometimes invisibly, sometimes directly interacting with us. From making our lives convenient to helping doctors diagnose diseases, AI is no longer science fiction, it is a part of our daily reality. But while AI is powerful and helpful, it's important to remember that it's not perfect. AI has limitations, biases, and ethical challenges that we can't ignore. Understanding these will help us to use AI responsibly and avoid unintended consequences. We have seen how AI can learn, adapt, and even outperform humans in certain tasks. It recommends movies, recognizes faces, drives cars, and plays Go like a grandmaster. But here's the truth: AI is not perfect, and there are many misconceptions about what it actually is. First, AI is not conscious. It doesn't think or understand the way humans do. When AlphaGo made that alien move, it was strategizing like a human. It was following patterns or probabilities it had learned from millions of games. Second, AI is not infallible. It can make mistakes, especially when trained on biased or incomplete data. For example, facial recognition AI has been shown to be less accurate for certain skin tones because of biases in the data it was trained on. Third, AI doesn't have morals or values. It cannot know right or from wrong. It only follows the objective it's given. That's why careful design, testing, and ethical oversight are critical when deploying AI in real-world scenarios. Consider self-driving cars. While the AI can handle most driving situations correctly, unusual scenarios like unexpected construction zones or unpredictable pedestrian behavior can still confuse it. AI is incredibly powerful, but it is not omnipotent. Or take social media platforms. They predict and recommend content, but they can also amplify misinformations or create echo chambers because they optimize for engagement and not truth. So AI is powerful, but it has boundaries. It's a tool, extraordinary, transformative, and sometimes surprising. But it's not magic, it's not human, and it's not flawless. The real challenge and the responsibility lies in understanding both its potential and its limits. When we combine human judgment with AI's capabilities, we unlock possibilities that were once unimaginable. And that, in essence, is what AI is all about: a partner, a tool, and a revolution quietly reshaping our world.